This video is about manipulations using the equations for cash flow from assets. I'm your professor, Dr. Stephen Haggard. In finance, we talk about two different equations for cash flow from assets, which here we're going to represent as CF parenthesis A. And the first equation that we're going to talk about is how those cash flow from the assets get paid out to the investors, because after all, that's who these cash flows belong to. In this equation, CFA is equal to cash flow from assets, CFB is equal to cash flow to creditors, the B actually stands for bondholders, and CFS is cash flow to shareholders. Now let's talk about how these things individually break down. What kinds of cash flows go to creditors? Well, first of all, we pay them interest. And secondly, we have the process of paying off old debt and taking on new debt. And so what we're really looking at here with cash flow to creditors is the interest we pay to them minus any net new borrowing. Well, how do we find net new borrowing? We take our ending long-term debt and subtract our beginning long-term debt. Now, often students get confused here and think that we're talking about total debt, but that's not the case. I have a derivation in the file on the cloud drives if you want to see why it is long-term debt and not total debt. But if you don't have access to that, just please take my word for it for right now. Cash flow to shareholders is similar in that we're looking at dividends. It's a cash flow to shareholders in the same way that interest is cash flow to creditors. And then we're going to subtract the net new stock issued, which is simply stock sold minus stock repurchased. And we'll talk here in a minute about how we calculate stock sold and stock repurchased. The first equation we looked at shows where the money goes to. This equation shows where the money came from. It's the operations of the firm and what kinds of investments we've been making, along with some changes in our net working capital. So our second equation is cash flow from assets is equal to operating cash flow minus net capital spending minus the change in net working capital. If you're unfamiliar, that triangle is the Greek letter delta, and we use it in science and mathematics for change. Net capital spending, or NCS, is equal to the ending net fixed assets minus the beginning net fixed assets, and we add back depreciation. The reason we add back the depreciation is because that ending net fixed assets has been reduced by the amount of depreciation over the year, and depreciation isn't a real cash flow, and so we don't want it clouding our work here, so we're going to add that back. Also, change in net working capital, simply the ending net working capital minus the beginning net working capital. But we have to remember that net working capital is also current assets minus current liability. So what we're really looking at here is ending current assets minus ending current liabilities minus, parentheses, beginning current assets minus beginning current liabilities, close parentheses. Now where are we getting beginning and end? In the balance sheet that you'll be looking at, you'll have 2 years worth of numbers. The ending number will be for the later year, and the beginning number will be for the earlier year. Operating cash flow, or OCF, is equal to earnings before interest and taxes plus depreciation minus taxes. Now, why do we add back depreciation? Once again, it's a non-cash expense, and it's already been subtracted out of EBIT, so we have to add that back. But we do have to subtract out taxes because taxes are a real cash flow. Now, why aren't we going ahead and subtracting out interest? That's because in finance we don't believe that interest is an operating cash flow. We think it is more correctly thought of as a financing cash flow. This argument often leads to fistfights between finance professors and accountants. So now we can put both of these equations together. In mathematics, the transitive property says that if A is equal to B and B is equal to C, then A is equal to C. Since we have two equations here that both say equal to cash flow from assets, those things also must be equal to each other. So on the left-hand side here, we have cash flow to bondholders plus cash flow to shareholders, and that's equal to, on the right-hand side, operating cash flow minus net capital spending minus the change in net working capital. Now we've seen before that these things all have subcomponents that are used to calculate them, so now we can substitute in those items. And so we see that the cash flow from bondholders becomes interest minus, open parentheses, ending long-term debt minus beginning long-term debt, close parentheses. Add cash flow to shareholders, which is dividends, minus, parentheses, stock sold minus stock repurchased, close parentheses. So that takes care of the left-hand side. On the right-hand side, OCF, for operating cash flow, is just EBIT plus depreciation minus taxes. Subtract net capital spending, which we said was ending net fixed assets minus beginning net fixed assets plus depreciation. Subtract the change in net working capital, which we said was the ending net working capital minus the beginning net working capital. Now we're going to take the equation from the last slide and distribute the signs. Because we have a lot of stuff in parentheses here, things can get confusing. So we can merely go through and we wind up with interest minus ending long-term debt plus beginning long-term debt plus dividends minus stock sold plus stock repurchased is equal to EBIT plus depreciation minus taxes minus ending net fixed assets plus beginning net fixed assets minus depreciation minus ending net working capital plus beginning net working capital. Now if you're a little confused, keep in mind that a minus times a minus is a plus. So if I distribute a negative sign into a parentheses and something has a minus sign in front of it already, that thing becomes positive. Now that we have things simplified out like this, it's quite easy to solve for any one of these things in terms of the others. Just in case you didn't think this was complicated enough, we can actually go in and make it even more complicated, because some of these things have equations that are used to determine them, and we could actually substitute those equations back into the big formula to make it even hairier. For example, net working capital is equal to current assets minus current liabilities, and our stock repurchased is equal to the treasury stock at the end minus treasury stock at the beginning. Stock sold is even worse, because in order to find the total common stock of the company, we always have to add common stock at par plus the capital surplus. We have to do that for the end and then subtract the same sum for the beginning. Now let's talk about the actual solving of a problem using what we've just talked about. First of all, you need to learn to recognize when this is going to be helpful. If you see that the question is asking for something and you think it has absolutely nothing to do with the other things in the problem, it's probably going to be solved using what we're talking about here. For example, if they're giving you information about dividends and interest and things like that, and then they ask you about the change in net working capital, this big equation is probably how you're going to solve the problem. So keeping that in mind, let's walk through the approach. The first thing that I would tell you to do with any problem in finance is to go to the end of the question and find out what you're being asked to calculate. Knowing that, it will help us to be able to look for the components that we use to calculate that. So often in finance, you actually get more information in the problem than you need to actually calculate the answer. And this tends to make students a little irritated. But I tell them that in the real world you actually have less information than you need to calculate the answer, and that I'm quite sure they would be even angrier with me if I gave them a problem like that. Okay, now that we know what we're being asked to calculate, we can go back to that big equation that we put together and solve it for that thing that we're being asked to find. Now that we've got that solved, set it aside. Let's go back now to the beginning of the question and write down everything that we're given. Now sometimes we'll be given the major components from the big equations, but sometimes we'll be given the subcomponents for those things. And then we're going to actually use those to find the components of the big equation. Make sure you do your math correctly and write those things down. Actually, don't write them down. Store them in your calculator. That way they won't be subject to rounding error. Finally, we're going to plug in the numbers that we found in step 3 into the equation we solved for in step 2 and calculate our answer.